Okay, now we know how to create, read, update, and delete data in the database, both from the shell and from Pymongo. So what's really left? Well, one thing you might want to do sometimes is atomically change a document and see its value either before or after the change. So if you think about having a document in the database, you can certainly find it using find one, and then you can update it using update one. But if you do that, there could be an intervening change. And there's no guarantee that the document that you retrieve from the database is the exact same one that you're storing back. Now, there's a general idea of find and modify that solves this problem. We're going to go over three different variants of this. They are find one and delete, find one and replace, and find one and update. And in all cases, these are going to find a single document, and then either they're going to delete it, they're going to replace it with another document, or they're going to update it. And in the case of updating, you can specify whether or not you want to see the document state from before the update or after the update. And this becomes very interesting, especially if you're trying to create a unique counter. And that's the example I'm going to show you today, which is how to create a unique counter in the database that's guaranteed to go up by one every single time you call it using find one and update. And before I go into that, I want to also let you know that if you look into the actual implementation of these commands inside Pymongo, you'll see that they all map to find and modify at the server. Now, the new CRUD specification states that the commands you use are find one and delete and replace and update. But if you go into the Pymongo code, you'll see that underneath they're all calling find and modify command at the server. Furthermore, in the Mongo shell, there's also a find and modify function. And that find and modify function also calls the find and modify command in the server. So this is another area where the shell has diverged a bit from the current state of the art inside the drivers. All right, let's look at our program to increment a counter. Here's our program called getSequenceNumber. Now this program imports Pymongo, and then it has one function called getSequenceNumber, where the sequence number is a name. Could be any string. And then what it does is it connects to the test database and the counters collection. And then it's going to call find one and update. The document it's going to look for has type name. So you can imagine having a bunch of different counters in this collection, each one represented by a single document. And then it's going to do an update. It's going to apply $inc to something we call value, which is an arbitrary key. We decided to keep our counter value in value. And we're going to increment it by 1 using the $inc operator. We're going to say upsert equals true. And the reason we're going to say upsert equals true is that we want this to work even if there is no counter document in the collection yet for this counter type. Now, if we're saying upsert equals true, well, then find and update can't return the document from before the update because that document wouldn't exist the first time. So instead of getting the document from before the update, we have a special parameter that we've set here inside this find one and update, where we've said the document we want returned by find one and update is the return document.after. Pymongo.return document.after. And if you look in the documentation, you can see this is a constant that is defined in Pymongo that specifies to the driver that you want to get the document after the updating, after the incrementing. So let's see what happens if we do this. So we're going to print getSequenceNumber for UID. So we're imagining that we're creating a unique user identifier. And by the way, you can see that what this function does, I didn't show you this part, is that it gets the counter value from the document that comes back. So we get back this document counter, and we get back this value right here. All right. Then we pull the value out of the document, and we return it. So that's what we're going to print in this getSequenceNumber. So let's run that a few times and see what happens. First, I want to show you that, in fact, there is nothing in this collection when you start. So db.counters.find, nothing in the collection. Now let's run using find and modify. We're going to run that, see what we get. All right, it ran it 3 times, and it got 3 different sequence numbers. Now we're going to do it again, and I got 3 more sequence numbers. And do it again, and I have 3 more sequence numbers. We've now counted all the way to 9. So what's inside the collection? Well, let's look. db.counters.find. We can see there's just a single document of type UID, value 9. And now that you see this, maybe it makes more sense what this program is doing, which is that it's looking for a document of type. We passed in the word UID, so type UID, and we've said that the update itself is $inc value increment by 1. Now, if we change this to -1, we'd be decrementing the value each time. And if we change it to -2, we'd be decrementing it by 2. I can show you that. Let's change this to -1. Now we're going to count down. And now we're counting down, and it should count to negative numbers as well. So this is how you create unique counters using find and modify. So find and modify is pretty useful, especially because MongoDB lacks transactions. And although each action to a document is atomic, if you want to get back the value and make a change all in one go without there being any intervening change, then you can do it using find and modify. Okay, so that's it. That's find and modify.